Welcome everybody to the ArjanCodes podcast. This is a new series that I've just started, and in this podcast I'm going to interview interesting people from the software industry and from academia. Today we're going to talk to Sybren Stüvel, who is a software developer at the Blender Institute. And you may also know Sybren as Dr. Sybren from our Discord server. Actually, Sybren is really a doctor. He did a PhD in computer science, and actually I was his PhD supervisor, so that's how we know each other. And for some reason, we are still on good terms. So thank you very much, Sybren, for joining the podcast today.
Thanks for the introduction, Arjan. So I'm Sybren, and I've been working at Blender as a software developer since 2016. I've been Blender developer since 2015 because during my PhD, we were looking at animating and simulating dense groups of people. And that simulation I ran inside of the Blender game engine. And that game engine didn't really do what I wanted it to do. So I started hacking it around and making it produce the information that I needed. So I started sending in that as a patch, and the guy reviewing these patches was Campbell. And I just poked him. Campbell, is it in yet? Is it in yet? Have you looked at it, Campbell? And after patch 3, he got annoyed by me, so he was like, hey, here you have your commit access, and now do it yourself. So that's how I became a Blender developer.
And Blender is based in Amsterdam, right?
It is, yes.
So it's founded by a Dutch guy, right?
Yep, Ton Roosendaal.
Yeah. When was Blender founded?
Yeah, well, Blender, the software is older than Blender Foundation or Blender Institute. It started in 89 already, as Ton started his company Neo Geo, which was a 3D animation studio that it started in his attic, and basically it grew quite rapidly and became the biggest company of its type, at least in the Netherlands. And then Blender started, like Blender, the software, he started it in January 94. And then in 98, basically Neo Geo had to close their doors, and Ton basically started a new company, not a number, with the intent of developing Blender further. That also was when Blender changed from in-house 3D application for some commercial company to being free to download for everybody. So that's when it started gaining a bit of a community. Then in 2002, Not a Number went bankrupt for various reasons, and all the intellectual property of the company was still owned by the financial backers of the company, which meant that it was no longer accessible for anybody. So that is when Ton started what was basically the world's first crowdfunding campaign.
Right.
And they collected with a quarter of a million users. So by then, even before Blender was open source, it already had a lot of fans. They raised over 100,000 euros in 7 weeks.
Wow,
so within
incredible.
2 months, yeah. And that money was spent on basically buying back the intellectual property and to make it open source.
So what is Blender's main model of survival?
Well, it changed over the years. So the first production was Elephant's Dream back in 2005. And I think that was funded by selling the DVD beforehand. So before the production started, you would already pay. So it was kind of a crowdfunding as well, except that the word didn't exist back then. But it was kind of paid forward. So when you pay early enough, not only do you get the DVD, but also you would get your name in the credits as one of the financiers of the project.
Right.
That, of course, is also really nice for people to have their own name in that film. And then Blender Institute was founded because Tom thought, well, this is a nice idea. And a bunch of other productions were made, like Big Buck Bunny and Sintel. But it was very difficult to get everything financed. And it's also very difficult to like basically keep people paid between productions. So that didn't happen. So it was really like scrounging people who wanted to make and were able to help with the production to make it. But then afterwards, like their contract couldn't be extended because there was no money left.
Right. It sounds very similar to what also happens a lot in the game industry, where game companies basically hire a team for a particular game, but then basically at the end everybody's laid off again. And the disadvantage as a business is that you kind of have to start over again from scratch when you start a new project. And often the good people already moved on to different places, so they're hard to find. So that must be really challenging.
Yeah.
And so you mentioned Blender Foundation and Blender Institute. So what can you explain a bit? What are those? How do they operate?
Blender Foundation is literally a foundation. It was started. I have to look it up in my notes because I wrote down the history a little bit. It was founded in 2002 when Not a Number went bankrupt and Blender had to be made open source. That was when Blender Foundation was started, and still it is the owner of the Blender sources. So it protects. It protects the intellectual property. It is the owner of the logo, for example. So you're free to copy the sources, make your own copy of the software, but you're not allowed to call that Blender with the official Blender logo.
Right. Makes sense.
And so Blender Foundation also protects developers. So if you give away what you write in terms of software to Blender Foundation, and in turn the foundation protects you when, say, some big corporation comes knocking on our door saying, well, you copied our technique, well, then you don't have to defend yourself as an individual, but the foundation can help you with that.
Right. Now that's a nice structure. And then the institute.
The institute is for the practical stuff. So it's the working business. So the institute pays the rent for the building we work in. It employs people. So the foundation can give out grants to specific developers to do a specific job. But when you want to have like a contract and have an employer, that's Blender Institute.
Right.
And recently another entity was spawned, which is the Blender Animation Studio, which is now separate. So the Animation Studio runs Blender Cloud, which was created to give more continuity. It's a website where people can pay €10 per month, get some discount if you pay per half year or a year. And then they get access to all kinds of training material behind the scenes of the production. And the training is also done by the people making these productions. So you really get professionals talking about what they do. And because of that, and because of that structure of having subscriptions, all of a sudden the studio had a more steady income, which meant that people could stay on board and we didn't have to lay off and then rehire and then etc. And then there is the foundation that receives donations.
Right.
And that was always possible. But a few years ago, we really wanted to make that bigger and wanted to make it normal for companies who make money with Blender, who also financially depend on Blender being available to them, to make it normal that they give to the Blender Foundation. So if you want to make money with Blender, that's all fine. If you want to do it, if you can use it for free, make money, keep the money, that's all fine. But if you want to contribute to the future of Blender, make sure that bugs keep getting fixed, etc., you can get a development fund membership.
Right. Yeah, I think for companies it makes a lot of sense to do that, because if you're using Blender professionally, if you're in part financially dependent then on Blender being able to provide what you need it to do, then it makes sense that you pay for it so that you also help support it in the future, and so that it can exist also in the future.
Yeah, exactly.
Yeah. Hey, Sybren, let's talk a little bit about the software design aspects of Blender, because I think that's particularly interesting. Honestly, if I look at, let's say, I mean, people develop lots of different kinds of software applications. I guess if you're developing a graphics tool like Blender or even 3D Studio Max or Maya, I mean, those are some of the most complex tools out there. I mean, they directly interact with graphics hardware. As you said, there are lots and lots of different components that have to operate together. They often have some kind of scripting engines, lots of importing, exporting facilities, render farm support, you name it. So there's so many extremely complex aspects to being able to build a software like that, and how to make sure it doesn't crash basically every 5 seconds. So can you say something about the overall software architecture of Blender? What is the Blender way of approaching that problem? How do you solve it?
I think a lot of this goes back to Ton's original design, which you can find back in, for example, the file format itself. Mm-hmm. It is basically a dump of the memory of Blender,
right?
And then some description of what that dump, like what that memory looks like. Mm-hmm. And then when loading it in, you can just load it back into memory. You know which version of Blender saved it, because that's also stored in the file. So you can do some versioning and upgrading of the memory to adhere to what is currently running in the software.
Yeah.
And then it keeps working. So you can still open a Blender 1.0 file in current Blender. Mm-hmm. May not have all the same possibilities, but
sure,
still. And this is because it's like based on data blocks. So a mesh is a data block, an object is a data block, and it's all very data driven. And that is what you see a lot in Blender. So, for example, when you make a user interface, many add-on developers want to know, like, how do I create a slider? How do I create a checkbox? I want to have that here.
Yeah.
And your life becomes considerably easier when you realize that Blender is more data-driven than that. So instead of saying, I want to input meters here, you want to create a property of a floating point type and add some metadata that says this is a distance. Mm-hmm. And then you just tell Blender, just draw this property. And because it has all that metadata attached to it, it knows that it should be a slider. And in that metadata, you can also give a minimum, maximum, that kind of stuff. And it will happen automatically.
Right. So Blender kind of decides what the interface is going to look like based on the data that you give it. That's exactly. Basically what you're saying. Yeah. Okay. Yeah.
And this is like this last part, that how you define these properties, how you define that metadata, is something that wasn't there in the very first version. So Blender has a DNA and an RNA system.
Yeah, that was going to be my next question. Because my software doesn't have DNA, so I was really curious what that actually meant.
Yeah. Let me start by apologizing to biologists or anybody who knows a bit about genetics.
I don't think they're watching this channel, so no worries.
So those data blocks that I talked about, that is the DNA of Blender. Mm-hmm. And it's to go into a bit more technical details, it's written in C, and they're just C structs.
Right.
They're defined in certain files in Blender that are then parsed by a thing that can just parse the source code, and that can write descriptions of that to a blend file as well. Mm-hmm. So it actually parses the sources and stores the structure of those structs in the blend file. Mm-hmm. So that when you load it, it can be parsed. And you can say things like, if this struct doesn't have a field of that type, then we go and do something to set the defaults correctly, or to compute the defaults from some other property. For example, recently we added a three-dimensional scale to custom bone shapes. Mm-hmm. So it used to have one number for the scale, and now we want to have a vector so you can scale it in X, Y, Z directions independently. That has to be initialized from that original one-dimensional scale. And this happens in the versioning code.
Mm-hmm.
So that is what the DNA system takes care of.
So with Blender, so you have an immense code base, I imagine, and you have many different contributors. How do you manage that, and how do you ensure some kind of quality process with all these different people that are involved, people that are not in the office or they're not part of Blender? So how do you go about that?
The one thing that's really important is code review. So many of the contributions come in from people who only do one or two contributions. Mm-hmm. So there is a code review system in place, so everybody can shoot us a patch and get it reviewed. Then there's the module system that gives us some guidance as to, okay, which part of the code is being touched by this patch, what's the topic of this patch, mm-hmm. and then it can be tagged with that module so that people can the right people can look into it. What I try to do with the animation module is that I include artists. So it's not just developers who are a member of a module, but mm-hmm. it's also animators and riggers who are members. Mm-hmm. So I will certainly also include them to get a feel for how useful a feature actually is. Mm-hmm. Like if it's a very technical thing, like I reduced the cyclomatic complexity of this function by 25 points and it's still doing the same thing, then it's not that interesting for mm-hmm. artists. But when it's a new feature or a change in behavior, mm-hmm. That's really important.
Yeah. And one of the big things of Blender is obviously that you have extensive scripting built in everywhere, basically. And Blender, so you said Blender is built in C, or maybe even C++.
Originally built in C, and
right.
we're moving more and more code to C++. Yeah.
And the scripting is all done in Python, right?
Yes.
How do you maintain that integration, and how do you make sure that it still keeps making sense? Because with scripting, I mean, you give a lot of freedom to your users, but it's also very risky because they can break all kinds of things, and it may lead to lots of support issues and other things that maybe you didn't think about when you were designing the feature or when you added the scripting.
If you put your mind to it, it's very easy to crash Blender with scripting. You can generate millions of objects that are way too big and clones of each other and not efficient. And that will just, if it doesn't bring your computer to its knees, it will certainly not, your GPU won't like it when all that data is uploaded to it. Mm-hmm. But still, it helps a lot. So if you think about what should we do in C++, and what should we do in Python, then as a rule of thumb, it's still do it in C or C++. Mm-hmm. And Python was really intended to build menus, build the user interface, glue things together, and not so much as to provide core functionality of the program. Yeah,
that definitely makes sense. Also in terms of performance of C++ is much higher of course, than Python.
Yeah, the idea of Tom was also that like the user should be able to do what Python can do and vice versa. But like what the user does should, in theory, all be in C or mm-hmm. C++.
Sybren, you mentioned DNA, but you also mentioned RNA. Can you tell a little bit more about that? How does that work?
Yeah, so DNA is really at the core of Blender, which is why it's called that way. And RNA is something that came later and was given a name that also relates to genetics, but it's like biologically the relation is different than here. Mm-hmm. Basically, it's the interface that the animation system uses and that also Python uses to access the DNA. Mm-hmm. So DNA could say this is a float property. RNA could then says, okay, this is a float property in RNA with this minimum, that maximum. It is a distance, or maybe it's an angle, and then the user interface will represent it differently. Mm-hmm. So it is the interface between the core data structure and how the animation system and Python interacts with it.
So it contains constraints like minimum and maximum length and the type of thing, and
yes, and things like maybe some property gets a setter function, getter function. It can register update handlers that are called whenever a property changes.
Okay.
And this also this RNA layer also plays a role in the override system. So with Blender, you can open a file, you have in memory what that file contains, what you can work with. But also you can link in data blocks from other blend files. So you can load in the character from the character file into an animation file and link it in. That means that when you save that blend file, it doesn't also contain a copy of the character. But as a design and user rule, you cannot edit anything that is not part of the current blend file. So when you want to pose a character that you linked in from a different blend file, well, you can't because it's a different blend file.
Right.
And this is where the override system comes into play. So you can say, I want to create an override for this armature and then pose it differently. The animation data gets stored in the local blend file. You can still manipulate that object, but the real copy actually exists in a different blend file. And this is also handled by the RNA system.
What would you say has been the main software design challenge for Blender in the last years?
I think it is trying to keep things more independent. If you look at a graph of the different modules, because the source code is not all in one file, of course. It's separated over multiple files, separated over multiple directories. Every directory becomes a library, and that is in the end linked together. If you look at the dependency graph just of these libraries, that is a huge entangled mess. Yeah. So it becomes really hard to figure out when you change something, what will be the result of that change. And I think that is the biggest challenge that we have at the moment, to get things more predictable and simpler to work with, to have clearer interfaces between one part of Blender and the other, instead of just everybody calling everybody's functions.
I imagine that this is really hard to solve, because especially if you just basically split out the roles a bit more, that people are responsible for specific sub things. They may not be interested in all the other parts and how they work, or it may not be clearly on their radar. So when you split the roles in that way, it might actually become harder to maintain a level of stability in the system.
Yeah, and you can see that in the time that it takes to make a new feature. Ton sometimes jokingly says, like, "Oh, when I was working on Blender, I could make a new render engine in a weekend." And that's no longer possible.
No, I guess it's the bane of every bigger software product, that at some moment you just can't move as fast anymore.
And also, like, it's still the same source code. There is still sometimes I go diving for a bug. Like, I go spitting in the Git history to figure out where it came from. And sometimes I end up at 18 years ago, initial commit.
Wow.
And
One thing that I was wondering about, so there's been a lot of developments in computer graphics, obviously, and over the last decades. Now we see VR, augmented reality, is getting really popular. We also see that, on the other hand, mobile devices become used more and more for professional applications as well. It's not just to check Facebook, but there are also video editing programs on your phone, for example. What do you think will happen in the space of 3D modeling tools like Blender in that regard?
Well, there is already quite a few things going on in terms of virtual reality support. So Blender already supports virtual reality in the sense that you can start it in Steam VR, for example, and then walk around in your own set. You just see the 3D viewport, but then in VR. And I think there are a few patches now in the review for adding controller support, so you can actually pick up stuff and interact with the scene. So this is definitely something that is continuing. Also, I know that there are studios who combine motion capture data with and virtual reality with Blender. So they use a camera rig that is tracked in motion capture. So it's actually sitting on top of somebody's shoulder, and somebody is looking through some viewfinder.
Right.
But what they see is what the camera in Blender sees. And so you get this feel of a handheld camera that is operated by a person standing in the scene, which is completely different than somebody using their mouse to move a camera around.
Right. Yeah.
Similar example with a different technique to get the same result was with Cosmos Laundromat 2015 when that was released. The director took a handheld camera, just went outside to the street and started filming the street. And the fact that it was street was completely irrelevant, but it had a nice texture that could be easily tracked by Blender. So it was used to create these camera tracks that were then imported into the film. To get this handheld feel to the camera motion.
Do you have any tips for our viewers, listener on software development and basically how to become better at it?
I think most important to get better at writing software is talk with people. Talk with friends, with fellow nerds online, for real, wherever. And discuss, like, why do you think your code is good? What makes you proud of what you made in terms of the structure or how you approach a certain problem? Make a list of the assumptions that your code makes. Like, try to really line by line figure out, oh, wait, but because I'm dividing by this, that means it shouldn't be 0. Or because I'm dereferencing this pointer, that means it shouldn't be null. But that actually means that in like 500 steps earlier, some other function was called to actually fill that pointer. And try to just write it down in comments. Like, what does this function assume about the state of the world? I think those two things are really important because I noticed that a lot of bugs occur when somebody has a certain assumption, but it wasn't really clear in the code itself. So then somebody else comes along, doesn't see that assumption is there, breaks the assumption, and things crash.
Right. Yeah, I think it's really hard to not think further than the happy flow. And basically assume that your users are going to try to break everything and are not going to do the standard things that you expect them to do. And you just want your software to be able to deal with that in some way.
Yeah. I think of myself as a developer who has this on his retina and thinks about the users and what they can do, etc. But still, when I was happy with my code, I thought it was done well. I gave it to a tester. This was back at a different company where we had a dedicated quality assurance team. I gave it to the tester. He does 2 clicks and it breaks.
Mind-blowing.
It also shows that you cannot test your own code. As a developer, you're working on making things, on creating things, on making it work. And as a tester, your aim is to break things. And it's such a different mindset that it's really hard to toggle between the two.
Absolutely. Hey, Sybren, thank you very much for your time. It was really lovely to talk to you about this. And I'm really curious to see what is happening with Blender in the coming years. Thanks everybody for listening and joining in. And don't forget to subscribe to the channel. And hope to see you soon in one of the next videos.